Michael is a movie producer in Hollywood, always looking for the opportunity to be responsible for the next blockbuster. But how should he start? Like in every business, looking at what has been successful in the past might help to predict what could be successful in the future. So Michael starts up his computer and loads Blockbuster, his visual explorer for motion picture data. This tool inherits all the information available about movies, directors, writers, etc. that might be helpful while producing a new movie. It offers different visualizations, which allow intriguing insights into this business. These visualizations can furthermore be combined to maximize the knowledge gain and even answer the most complex questions. In the upper part of the Blockbuster user interface, you can see different tools, visualizations, and layouts that can be used on the data. In the basic configuration, Blockbuster displays information about 30,000 movies from the last 30 years in two different visualizations. The upper one is a zoomable table view called Hypergrid. It displays all movies in rows and columns, but furthermore allows to access details on demand by zooming into certain cells, thus making more information available to the user, including attributes like images or plot summaries. In the lower part of the screen, all movies are visualized in a zoomable scatterplot view called Hyperscatter. In this example, one can see the distribution between budget and the year of production. It is also possible to access a data point and get details on demand, similar to the Hypergrid, and by applying the same interaction concept. Even in this basic configuration, there are already some interesting insights visible. So for example, the Hyperscatter allows us to see that the budget of movies steadily increased during the years and has reached new highs just recently. In the Hypergrid, it becomes obvious that most of the movies performing well at the box office are PG-13 or PG-rated movies and not R-rated, explaining the efforts movie makers undertake to reach such a rating. But let's get back to Michael. He is interested in commercially successful movies of the past, and therefore he mainly needs information about box office gross and budget. His first step is to remove all movies that lack this kind of information. He therefore uses the table filter functionality by first filtering all movies without a valid entry for the total gross by budget ratio, and afterwards removing them from the current dataset. Now Michael wants to investigate the effect a genre might have on the chances of a movie to be commercially successful. He therefore replaces the Hypergrid visualization with a bargram visualization that allows him to see correlations between attributes and the distribution of each of them. He chooses genre and the box office by budget ratio as relevant attributes. If the gross by budget ratio is between 0 and 1, a movie can be seen as a commercial flop. So he moves over the different genres, enabling him to see the links between each genre and the box office by budget ratio. As you can see, the genre action movies seems to be pretty successful, since only a few movies really flopped. The same goes for the genre adventure. In the upper column, it is furthermore possible to see the relationship to the IMDb user rating. As you can see, producing a drama seems to be quite risky, since most of the movies are in the area of 1 or below and are rated relatively low. So Michael selects the action and adventure genres, since they can be considered as quite promising. As you can see, the corresponding items are filtered in the scatterplot below. Since Michael wants to use these movies also as a basis for the crew selection, he chooses to limit it to the movies from the past 10 years by zooming into this range within the Hyperscatter. He selects and adds those movies to his Favorites tab, which can be seen on the top right, by selecting them and clicking on the Add button. Within the Favorites tab, he now exchanges the Hyperscatter visualization with the Hypergrid visualization in order to explore the selection and judge the results on his personal knowledge. The Hypergrid allows him to directly watch trailers, read plot information or even scripts, and therefore makes it possible to decide whether a movie fits in his personal understanding of a good movie he would like to produce. He can also use the background visualization to filter the view, for example for movies rated rather bad. He then finds some movies which don't seem to fit so well, and he therefore removes them one by one from the dataset. In the next step, Michael would like to get more hints about story elements that should be considered when developing the screenplay. So he drops in another visualization, a network view. In the default configuration, this view is used to visualize movie keywords. These have been given by users of the popular movie site imdb.com. The visualization allows him to quickly see what keywords are used often among the selected movies and which of them are used together. He picks popular pairs and single keywords and adds them to his personal wish list. He then uses this network to visualize actors. He changes the appearance to a circle, allowing him to easily see correlations and highly active actors. So he would like to investigate which actors have been active in the past 3 years and have furthermore a good track record. He therefore uses a combination of network, bargram and hyperscatter visualization. By selecting all movies between the years 2005 to 2007, these are highlighted in the bargram as well. By combining these three visualizations, one can see which actors have been commercially successful in the past 3 years and which have not. So for example, when moving over Samuel L. Jackson, one can see that his recent movies were all commercial flops. He again adds several actors to his wish list, considering them for leading roles in his movie. He then undertakes the same approach to choose possible directors, writers, etc. The last step, before handing this selection over to his assistants for elaboration and refinement, is to further reduce the set of movies to examples in terms of budget and user rating. He therefore uses the hyperscatter visualization to quickly remove movies out of his budget range and with a relatively low user rating. Michael now selects the wish list from the Visualizations toolbar. This list summarizes all important attribute values, like the range of production year or the just selected budget range, as well as selected keywords and actors. Michael then can go ahead and export this list so that his assistants can continue to work on this dataset.